Hello everyone, in the last video we have already discussed what is the structure of ANN and how to calculate the number of weights between the layers. All these things we have discussed. If you missed out on that particular video, please check it out. Now let's move on to the next part. And before going into this particular video, try to comment down the number of weights in W0, W1 and W2, and you can check out like exact number by referring to the last video. If you check the last, you will clearly get to know the total number of weights. Okay, now let's try to understand what kind of problems can we solve with this particular ANN. So basically we know that there are two kinds of problems. One is regression and the other kind of problems are classification problems within supervised learning. And in classification, we can divide it into two types. One is binary classification problems, and the other one is multi-class classification problems. Okay, so regression, we have seen one algorithm, that is linear regression, which can solve the regression problems. And similarly, for binary classification problems, we have seen one algorithm, that is logistic regression, right? And for multi-class classification, we can't directly solve like multi-class classification problems with logistic regression. But like we can do something like let's say there are 10 classes, class 1, class 2, class 3, so on, class 10. What we can do is we can build 10 different models for each of the classes. Like first model 1 will tell whether it is class 1 or not, and model 2 will tell it is class 2 or not. Like that, like indirectly we might solve the multi-class classification problem, but directly we can't solve multi-class classification problem with the help of logistic regression. Okay, so these are the three kinds of problems that we have that we know within supervised learning, and with the help of this particular ANN we can solve all these three kinds of problems. Okay, we can solve regression problems, we can solve binary classification problems, and we can even solve multi-class classification problems. Okay, basically we can't keep everything same for all these three problems. We need to make some changes. Okay, so let's see what are the major changes that we need to make according to the problem that we have. Okay, the main change that we need to make is on the output layer. We know that this is our input layer and this is our hidden layer 1, whereas this is our hidden layer 2, and finally this is our output layer, right? The main changes that we need to make, if we have known that we are trying to solve regression problem, or if you are trying to solve binary classification problem, or if you are trying to solve multi-class classification problem, the main change that you need to make compulsorily is in the output layer. Okay, so let's see what all changes that we will be making in the output layer. So let's say the problem that we are trying to solve is kind of regression problem, or the problem that you are trying to solve is binary classification problem, or if it is multi-class classification. So based on these three kinds of problems, mainly we'll be changing these two things in the output layer. So first one is the number of neurons in the output layer. So here if you see, I'm drawing only one neuron, but it can change. So I might have several other neurons, and I might connect the previous layer outputs to all of these neurons. Okay, like this. So like that we can have as many number of neurons in the output layer that we wish. So let's see how will I change this thing. Okay, how will I fix the number of neurons in the output layer? So the number of neurons in the output layer for regression problem, it will be dependent on the number of outputs that we have. Okay, so many of you might think that there is only one output in case of regression, because the problems that we have like solved till now are like price prediction, height prediction, weight prediction. Like the problems that we have discussed are similar type, right, where there is only one variable that we need to predict. But in real time it can happen that we might need to predict 2 or 3 continuous variables. Like if you think of location, if you are trying to predict location can be combinedly predicted with the help of latitude and longitude, right? So both latitude and longitude both are continuous values. So that's why in case of regression also we can have multiple outputs that we can understand. So if you are having multiple such outputs, as we are having two outputs over here, in the output like in the output layer we'll be having only two neurons. Okay, so this third neuron will not be there in such case. And similarly, in case of binary classification, we might have either one neuron, or sometimes we can even keep two neurons. It is up to you whether to choose one neuron or two neurons. And in case of multi-class classification, it is based on the number of classes that we have. Okay, so let's say if you're trying to predict the handwritten digit, in that case the number of classes will be 10, and in some other application the number of classes might be 5. So based on the number of classes that we have, you can have those many number of output neurons in the output layer. Okay, so this is one of the change that will be making it in the output layer. And the other change is the activation function. Whenever you are trying to solve some regression problem, the activation function that you will use in general is linear activation function. So what is linear activation function? It is like f of x equal to x. That means whatever it takes as input, it will be giving the same thing as the output. This we have already seen in the perceptron video. Yeah, it is the same. So that is what linear activation function is. And then like for solving binary classification problems, especially when the like number of neurons in the output layer is 1, then we'll be using sigmoid. Okay, and if it is 2, then we'll be using softmax. We already know what sigmoid is. We have discussed this in case of logistic regression, and softmax will also work similar, but it will be giving it for multiple neurons. Okay, we might be discussing this in future or maybe in this video itself. Okay, and in case of multi-class classification, also the activation function that we will be using is softmax. Okay, so these are the main changes that we'll be making according to the problem that we have. So if it is a regression problem, the number of neurons in the input layer will be equal to the number of outputs, and the activation function that we use is linear. And similarly, if it is a binary classification problem, either we can keep 1 or 2. If it is 1, we'll be using sigmoid, and this is the combination that we follow the most. And if it is 2, then you can use softmax. And similarly, if in case of multi-class classification, the number of neurons will be equal to the number of classes, and the activation function is softmax. Okay, so let's try to understand in this particular case. So let's say if you are trying to solve some binary classification problem. So in binary classification problem, we might have one neuron, and the activation function that we'll be using is, it is sigmoid. Okay, if it is binary classification problem and one neuron, and if it is binary classification problem and two neurons if you are having, then you will be using something like softmax. Okay, so activation function that you'll be using on the final layer will be softmax. And what softmax will be doing is, let's say this is correspondent to class 1 and this is correspondent to class 2. We might be having two classes, right? As it is a binary classification problem, we might be having two classes, and in softmax we'll assume that this is belonging to class 1 and this is belonging to class 2. And what this will be returning is, or what this will be giving if we apply softmax as our activation function is, it will be giving us the probability score that this particular input, whatever input that we are passing, that is x1, x2, x3, x4, this input is belonging to class 1. So that probability score it will be giving. Given this input, the probability score that it being class 1 is given by this particular like the output that we get from this is equal to the probability score. And similarly, the output that we got from this one is the probability score of it being class 2. So like that, softmax will be working. Whereas if you are having only one node, then it will be signifying, it will be just giving some value between 0 and 1, that you can think of it as like probability score. If it is greater than some threshold, you can think of it as class 1, and if it is less than that threshold, you can think of it as class 2. Okay, so like that you can think in case of sigmoid. Whereas if it is some regression problem, then the activation function that you will be using is linear. Okay, so I hope You got some clarity in what changes that we make according to the problem that we have. And now let's try to understand the other important aspect, that what are parameters and what are hyperparameters in case of ANN. Before moving on to that, let me remind you what parameters are exactly. So parameters are the variables which are adjusted by ML model, whereas in case of hyperparameters, hyperparameters are the variables which are adjusted by us. Okay, so model will not adjust them, will only be adjusting them. So now, according to your understanding, in this particular ANN model, what do you guys think parameters are and what are hyperparameters? Okay, please comment down your answer in the comment section. And that's it for this video. And we'll continue the same in the next video. So thank you everyone. Bye bye.